Hello students, welcome back to a new mathematics program for grade 9. Today we're going to talk about indices. This is a chapter that you have already covered in grade 7 and in grade 8, where you learn some rules and laws of indices. For this year, for grade 9, you're going to learn some more rules of indices. Well, this video is the first part of a series of 2 videos based on this chapter. First of all, let's have a look at what you're going to learn in this very first video. Students, in this program, you're going to revisit the definition of indices, how to write a number in index form, and some laws of indices learned in grade 7 and 8. But first of all, let's have a look at the definition of indices. Consider this number. We read this number as 2 raised to the power or index of 3. This number 3 is called the power or index, and the number 2 is called the base. Note that we say one index, many indices. So in this chapter, we're going to deal with manipulation of indices. In fact, power or index is used for repeated multiplications. That is, if we have 2 raised to the power or index of 3, it is same as 2 times 2 times 2. Remember that this number 2 is called the base, and the number 3 is the power or index. That is, here we have the base being repeated 3 times. That is, the base is repeated the number of times indicated in the power or index. Consider 2 to the power of 3, which is equal to 2 times 2 times 2. This 2 raised to the power of 3 is called a number in index form, whereas the 2 times 2 times 2 is called the expanded form. Let's have a look at some more example, where here you can see that 3 to the power of 2 is in index form, whereas 3 times 3 is the expanded form. Similarly, for 5 raised to the power of 4, it is same as 5 times 5 times 5 times 5. M to the power of 3, it is same as m times m times m. Students, remember that in grade 7, you learned about some laws. Firstly, you learn about the multiplication law, which states that if you have a power m times a power n, the answer is a power m plus n, where the base remains unchanged. Then you learn about division law, where a power m divided by a power n can be written as a fraction. That is, we write a power m in the numerator and a power n in the denominator. The answer for this is equal to a power m minus n, where a cannot be equal to 0. That is, the base should be a non-zero number. Then you learn about power law, which states that a power m power n, it is same as a power m times n. And then you learn about the meaning of a power 0. That is, any number raised to the power of 0 is always 1. Now let's have a look at some examples where we use these laws. Firstly, if we have a power 3 times a power 2, where the bases are same, so according to multiplication law, we need to add the powers. That is, the answer is a power 3 plus 2, which is equal to a power 5. Now, if we have 3a power 3 times 2a power 2, you will notice a numerical value in front of the element in index form. So in this case, you need to multiply these two numbers first, that is 3 times 2. Then we apply multiplication law to the elements in index form, that is a power 3 and a power 2, Applying multiplication law, you will have a power 3 plus 2. So the final answer is 6a power 5. Now, if we have 12m power 7 over 3m power 4, first we are going to divide 12 by 3. Then we are going to apply division law to m power 7 divided by m power 4. So we'll have 12 over 3 multiplied by m power 7 minus 4. Because applying division law, you are going to subtract 4 from 7 to obtain an answer of 4m power 3. Now look at this example where you have power law, multiplication law, and division law. So first we are going to use power law. That is, if we have p power 2 power 7, we are going to apply power law to obtain p power 14. Same for p power 4 power 2, which is equal to p power 8. That is, we need to multiply the two powers, 4 by 2. Then in the denominator again, you're going to apply power law, p power 11 power 2. It is same as p power 11 times 2, which is equal to 22. Now we are going to use multiplication law to simplify the numerator. According to multiplication law, you need to add the powers. So 14 plus 8 equal to 22. In the denominator, we already have p power 22. Now we apply division law. According to division law, you need to subtract the powers. Now 22 minus 22, it is same as p power 0. And you also learn that p power 0 is 1. Any number raised to the power of 0 is always 1. Students, in grade 8, you learn about some rules of indices. Namely, if you have AB power m, it implies that this power m belongs to both A and B, which are found inside the bracket. So AB bracket power m is same as A power m times B power m. Now, if you have A divided by B inside a bracket with power m, again, this power m will belong to both A and B. That is, it becomes A power m divided by B power m. Rule number 3, negative indices. Now, if we have A power minus x, this can be written as 1 over A power x. That is, the negative power becomes the positive power, but provided that we write it in the denominator. So A power minus x equal to 1 over A power x. Rule number 4, we are going to use power law involving fractional indices. That is, if we have A power x inside bracket, then power 1 over y, you have two powers here. One is an integer and one power is a fraction. So if we apply power law here, you're going to multiply x by 1 over y. Now, let's have a look at where and how we use these rules. Number 1, 3a inside bracket power 2. That is, we have 3a power 2. Here, this 2 will belong to both 3 and a. So it becomes 3 power 2 times a power 2. Of course, 3 power 2 is 9. So the answer is 9a power 2. Number 2, 3/4 power 2. That is 3 over 4 inside bracket. Then you have power 2. Here again, this power 2 will belong to both 3 and 4. You will have 3 power 2 over 4 power 2, which is equal to 9 over 16. 4 power minus 3, that is negative indices. This becomes 1 over 4 power 3. Now you can simplify 4 power 3. 4 power 3 is 4 times 4 times 4, which is of course equal to 64. So the answer here is 1 over 64. 125 power 1/3. Here, to be able to evaluate this number, first you need to write the 125 in index form. It becomes 5 power 3. because 5 times 5 times 5 is 125. Here we have 5 power 3 power 1/3. 5 power 3 is inside the bracket, then you have power 1/3. So you are going to multiply 3 by 1/3. In multiplying 3 by 1/3, the number 3 will get cancelled. You will be left with 5 power 1, which is of course equal to 5. Fractional indices. Remember that in grade 8 you learned that square root of a can be written as a power half. Similarly for cube root of a is same as a power 1/3. In general, the nth root of a is same as a power 1 over n. In other words, we can represent square root using the symbol, or you can represent square root as power half. For cube root also, either you use the symbol for cube root or you use power 1/3. Now let's have a look at some examples using fractional indices. First, evaluate square root of 25. So 25 power half is same as square root of 25. Writing 25 in index form, you have 5 power 2 power half. Multiplying 2 by half, the 2 will get cancelled. So the answer is 5. Cube root of 64. Writing 64 in index form, we have 2 power 6. So we have 2 power 6 power 1/3. We need to multiply 6 by 1/3. When performing this multiplication, it's same as 6 divided by 3 equal to 2. We have 2 power 2 equal to 4. Third part, square root of 81. So 81 can be written as 3 power 4. Multiplying 4 by half, you have 2. 3 power 2 equal to 9. We usually use this method to find square root of larger numbers. Here, you need to evaluate cube root of 216. 216 power 1/3 is same as cube root of 216. Writing 216 in index form, you have 2 power 3 times 3 power 3. Now you learn that this power 1/3, it belongs to both 2 power 3 and 3 power 3. So you have 2 power 3 power 1/3 multiplied by 3 power 3 power 1/3. The 3 will get cancelled to end up with 2 times 3, which is equal to 6. Now students, I'm going to give you some exercises for practice. In these exercises, you need to use the different laws and rules of indices. Second exercise for practice, you're going to evaluate these numbers. So students, in this program, you have done a recap on definition of indices, how to write a number in index form, and some laws of indices learned in grade 7 and 8. If you need some more information on this chapter, here are some links. So students, this program ends here. In this program, we talk about indices. We have done mainly a recap of whatever you have learned in grade 7 and in grade 8. Remember that this is the first part of a series of 2 videos based on this chapter. So see you soon for the second part of this chapter. Till then, goodbye.